As I mentioned several times, I hope you will become, so to speak, allergic to anything that has a negative leading coefficient. So the numerator has x in common right away. This I will factor out -1, and I will get x squared minus 25, which factors into x plus 5, x minus 5. Voila, that's what I needed. Thank you. Okay, so I have to start my table. This solves two issues. One, the graph with a hole, and the other one, um, talking about the problem and solving it in class together with. Good. So I'm sure you will tell me that the domain is what?
All real numbers except 5 and -10.
Good. I'm going to try to make them as small as possible. So I know I'll probably have to maybe redo my table, but I have to explain and I have to put them in the table. If I have to redo it because there is not enough room, I'll redo it. That's not a big deal. Okay. So we know that a function is undefined at those points, x values, -5 and 5. Now, only now, I'm allowed to simplify. And the simplified form is x over x minus 5. Because x minus 5 still does not disappear, x equals 5 is a VA. Because x plus 5 disappeared, x equals -5 is a hole in the graph, not a VA. I need 1, 2, 3, 4, 5, 6, 7. Okay? I have to plug in 0. What do I get when I plug in 0? Anyone?
0.
Thank you very much. And now I need these limits. 1, 2, 3, 4, 5, 6. Okay, so let's start with the simple ones. As x approaches -infinity, from -x over x minus 5. What do we get? And I'll put it here. Anyone? Well, it's infinity over infinity. I will use L'Hopital's rule. The numerator is 1, the denominator is 1, so the answer is -1. I did not use plus or minus, so this must be -1 as well. And I write myself a note, y equals -1, horizontal asymptote. Now for the limit for the hole. Limit as x approaches -5 from the left of -x over x minus 5. And this has to equal, for sure, it has to equal the limit as x approaches -5 from the right. So these have to be the same. It's a hole. It's not like this. No, it's a hole. Something like this. So they have to be the same. So can anyone plug in here -5 and tell me what to write? Where does the top go?
Possible.
Yes, but yes. So the top is -5. Okay, what about the denominator?
This is on the left. Sorry, I was looking at that as a -5. Sorry.
No, that's okay. So this is not undefined. This cannot be undefined. So yeah, so the sign is in front. The numerator is -5. What about the denominator? Right, it's -10. 3 negatives, -1/2. This has to be -1/2. Plug it in, it has to be the same. -1/2, -1/2. The whole will be -5, -1/2. So it will be -5, comma, -1/2. This is the whole. One last step here, left and right. These will be infinities, no doubt. But I don't know the sign, so I have to calculate the limit to determine the sign there. Okay, I'm on page 2. So limit. As x approaches 5 from the left of -x over x minus 5, and limit as x approaches 5 from the right, -x over x minus 5. Can anyone give us those answers? Where does the top go? To 5. Where does the denominator go?
0.
Yes, but from which side? I mean, the sign. It is 0, but I need the sign.
From the
From the left means with 4.9.
okay, so from the right.
From the left with 4.9. So the sign. It is 0, but the sign.
Okay, so
4.9 minus 5, just the sign.
then that's negative.
Good. So the answer is positive infinity. And on the other side, with
Then it's positive.
it's positive 0 if you want. So this will be negative infinity. I shouldn't write this because there is no need. We're just discussing, but that's fine. So positive infinity and negative infinity. Done. Everything here is completed. Nothing else is needed there. Good. Now I go on to this first and then the second. Good. So I'm going to copy the function here is -x over x minus 5. So let's find f prime. The top function is 1, prime is 1, minus the top times the denominator prime, which is 1, over x minus 5, very nice, of course squared. Top 5, x minus 5 squared. Always positive, never 0, beautiful. No critical numbers, no max min. Okay, now I'm checking my table. Moment of truth. So let's see. From -1 to -1/2, yes, that's true. From -1/2 to 0, yes, that's true. From 0 to infinity, yes, that's true. From -1 to -1, yes, that's true. Now the second derivative. Second derivative, after I write the first derivative like this. So now the second derivative, bring down -2, so it's positive 10, x minus 5 to -2 minus 1, which is -3 times the inner function prime, which is 1, yay, 10 divided by x minus 5 to the third, but I will rewrite it for the study of the sign like this. You can say, what's this? Well, it will just tell me that I do not need to plug in here. I only need to plug in here. This piece will dictate the entire sign. These two mean nothing for the sign. Okay? So then, to the left of 5 is negative. To the
Really quick.
Yes, I'm
Just
here.
to make sure I understand the purpose of that. Is that because that's an odd number and we could even
Exactly.
I got
This is
Okay.
carved in stone being positive. This is carved in stone being positive. If I had a 2 or a 4 here, I don't need to do that. It's always positive.
Okay.
Exactly. Because
Okay.
it's power 3, I don't want to have to cube anything. I just have degree 1 to deal with. To the left of
Yeah.
5 is negative, to the right of 5 is positive.
Okay. I missed that step last time.
You don't have to do this. This is for lazy people who do not want to use a calculator too often. If you want, you can just put this in the graphing calculator and plug in numbers to the left of 5 and to the right of 5. But I, on the other hand, prefer to think more than punch in numbers. but it's not important, really. Plug in the calculator and punch in numbers to the left and to the right. Instead, I'm just thinking in these terms, and I know that this is a linear function. I don't have to think in terms of q. This piece is a linear function. It has to come from negative, cross the x-axis, and go positive. So I have the sign, and it crosses at 5. So I know that this is negative and this is positive right away. But you can plug in numbers, right? So here it does not hold water, and here it does. No inflection points. This is never 0. No inflection points. It just changes concavity, but no inflection points. And this is it. I don't need anything else other than I can have to write symmetry. And the symmetry, if you remember, I have to calculate f of negative x. It will not equal negative f of x, and it will not equal f of x. How do I know? When I replace x by negative x, the function changes. It's not odd and it's not even. So this is the only thing, if you remember, and the slant asymptote that does not fit in my little table. I don't take credit for it. I was taught this way a million years ago. And I will not take credit for it, promise. Okay, so now let's graph. When we graph a function with asymptotes, we have to graph the asymptotes first. Okay. Function has two asymptotes, x equals 5 and y equals -1. I want to get rid of this quickly. -5, -1/2. 0, 0. Okay, now my table tells me what to do. From -1, it increases to this point, which is a hole, goes through the origin, and goes to infinity. All increasing and all opening down. I'm thinking, how can it be opening down? Makes no sense. It makes no sense. My signs are wrong.
I think for the second derivative that they're positive.
Say it again.
For the second, like when I did my numbers, in the second derivatives of it in your chart, I have positive from negative infinity pretty much to 5, and then it goes downward from 5 to infinity.
Oh, yeah, Janelle, that's what I have too.
Because I copied -5 here. See how I catch my mistakes? It makes no sense. This cannot be. And here's what happened. This was positive, but I copied negative here. See my error? From here, I copied a minus in front. So that's all I want from my students, to say, oops, something is wrong. Okay, so that's why I have negative here. Excellent. So from here, I looked for by mistake on this side instead of copying this here, right? So it's +5 times x minus 5 to -2. Bring down, and I have -10. So it's negative and 10 over this. So please correct that. Thank you. Because it's not possible. How did I find out that? Because the function has to do this. It cannot do this. I mean, it has to approach asymptotically. So I said, oops, something is wrong. And I found my error. It's right here. Okay? So it is indeed. So this is positive still. But now this has a negative leading coefficient. So obviously it's positive and negative. So I have to correct my table. Thank you very much. So it's positive and this is negative. Thank you. My signs are wrong. A little thing. It couldn't be. It didn't make any sense. Great. Now it's fine. Good. So from -1, it increases to -1/2 with the whole, going through the origin, going to positive infinity. From approaching asymptotically through the origin, through the whole, and going to infinity. On the other side, coming from -infinity, opening down, always increasing, approaching the asymptote, approaching asymptotically, in other words. This is what I mean. Good. This is it. So this is f of x, which is x squared plus 5x over 25 minus x squared. Good problem. Thank you. Next question. Anything. Sean, is this clear now? All steps?
Yes. I got stuck somewhere.
That's okay. That's okay. Anyone else? Other questions? Anything else? Web assign or otherwise? Yes. Yes, I'm ready.
Number 72 from the same section in 4.5.
Yes. Let's take a look. 72. 72. This one, what are we asked? Just find the, oh, use the, okay, so the whole thing, including the slant asymptote. Very good. So we have y equals x to the third over x plus 1 squared. Okay. So I will start with a domain. Can anyone give us the domain of this function?
It's -infinity to -1, union -1 to infinity.
That's it. Awesome. It doesn't go away, so I know x equals -1 is the vertical asymptote. When I plug in 0, I get 0. Now, all I need to determine about the function are these limits. And then I can move on to the first and second derivatives. So let's find the limits. So limit as x approaches -infinity from x to the third over x plus 1 squared. This is infinity over infinity. I will use L'Hopital's rule. So 3x squared over 2x plus 1. Again, infinity over infinity. Limit as x approaches -infinity, 6x over 2. I simplify. So when x approaches -infinity, this is -infinity. So the process will be identical for x approaches infinity, and when I plug in infinity, it will be infinity. Good, so now let's find the limits left and right. And I'm on 4. Okay, so limit as x approaches -1 from the left, from x to the third, x plus 1 squared. I know that this has to be infinity. There is no discussion there. I only need to find the sign. So -1 from the left, the top is negative for both. And this is always positive. No matter what I plug in, it's squared. So negative over positive will be negative in both cases. So x equals -1, as expected, is a VA. So that is done. Both -infinity. Now first the second derivatives. So I'm copying f of x right here, x to the third, x plus 1 squared. Yes, this could be a little messy, so let's see. f prime of x, 3x squared, x plus 1 squared minus x cubed times 2 times x plus 1 over x plus 1 to the fourth. Do not multiply. If you do, it will take forever. So factor out. I'm going to factor out x squared and x plus 1. So x is outside, 3 is still left in, one of those is out, so I have an x plus 1. This is out, x squared is out, minus 2x. This one will go away. X squared, this is 3x minus 3 minus 2x. It cleans up quite nicely. Okay, so this is x squared, x minus 3 over x plus 1 cubed. So there are 3 solutions, but actually x equals 0 and x equals negative 3 when you set this equal to 0. Back to my table. 0 and 3. Back to my table. 0 and 3. One more time, just making sure. Yes, so I need a sign. So for the purpose of the sign, remember this is x squared, x minus 3 over x plus 1 squared, x plus 1. Because this is useless when it comes to the sign. So when I plug in negative 10 over negative 10 will be positive. When I plug in negative 0.5, this is positive, this is negative. When I plug in 1, negative. When I plug in 10, positive. Now the moment of truth. You can put this in the graphing calculator and just punch in numbers. Negative 10, I get negative over negative. Negative 0.5, I get negative over positive. 1, I get negative over positive. And 10, I get positive over positive. I need the signs to make sure that my table works. Okay? So now let's see. I'm thinking for a second. I don't like this thing. So let me also plug in 3 here. So when I plug in 3, what do I get? 27. I need this value. So f of 3 is 27 over 3 plus 1 is 4. 4 squared is 16. My calculator, I just need to see what this is. 1 point what? Approximately 1.7. Because I need it in the table. Okay. I have to check my numbers here. Just 1 second. Because here is very simple, what I notice. I know there is some error. How do I know that? Very simple. Let me